Okay, so right now we have the default first-person character controller. For the grapple, we want to set up a few things. We want to set up the isGrappling variable, the current grapple point, this is the point in the world space where we are grappling, the current distance, this is the max distance that the grapple can go at its current moment, and then the max grapple distance. So this is the max you can do to start, whereas the current will only pull you if you're going further than that grapple distance. It'll make sense as we go further along. Now we're going to want to add some properties to it. So U property, blueprint read only. This means in the blueprints you can't modify this, you can only read it. And then replicated means when it's called on the server and changed, that change will be sent to all the clients. We do the same for the grapple point and the grapple distance. And then for the max grapple distance, we want to set it differently to edit anywhere, and then category equals grapple. So we also want to do blueprint read only. And so the edit anywhere will make it so that in the side panel on the Unreal Editor we can modify this. So maybe we want the character to have a shorter grapple distance, we can change that. Next, we want to make sure that these replicated properties are actually replicated, so we need to override this getLifetimeReplicated_props function. So now in here we want to do rep lifetime, and this is declared in the Unreal Network header. And we put our character class, and then we put our replicated variables. So we want isGrappling, and then we want to do current grapple distance and current grapple point. So now I want to set up the points that set the grapple remotely. So first we want to have a try_set grapple local. This will do the trace and then try and set the grapple point. This will set the grapple point locally. This will be called and it will set the grapple point on the server. And so how this works is the server modifier makes sure that if this is invoked on the client, this gets executed on the server. And reliable means that if the connection fails for some reason, this will retry. This is for one-shot things. Unreliable should be used for things like health bars or times that are constantly changing, where if you miss an update, it's not really a huge deal. Next, we want to have isGrapplePoint valid. This is just going to check if the grapple point is valid so we can check against cheating. We can expand upon this further later. And then apply grapple. This will apply the forces to the character when they are doing the grapple. We also need the stop grapple local and stop grapple remote functions, and the remote function also needs to be server and reliable. Another thing we're going to want is register new grapple point. Forgive me, isGrapplePoint valid should return a bool. Okay, first things first, we're going to do the line trace for the grapple. So this is the try_set grapple local function. First, we want to get the camera component because that's where we're going to trace from, because we want the camera to be the user perspective and we want that to be where they're starting from. The start is the camera location, the component location. The trace max distance is 10,000 just because it's pretty big. The end is the start location plus the forward vector of the camera times the trace max distance. Then we want to create collision query parameters and add this to the ignored actors because we don't want to accidentally hit ourself in the trace, because then we would grapple onto ourself. It would make no sense. Then we create a hit result to contain the out hit data from the line trace that we have here. And the trace channel ECC visibility will basically trace for anything that you can see. That might not be what you want. You might want to have a custom channel, but you can look into that on your own. And then in here, we want to use the impact point from the out hit and set it to the grapple point local function. Okay, so now in our set grapple point local function, what we want to do is call our register new grapple point function. And inside of that, we're going to check if the grapple point is valid. And then we are going to set the current grapple point to the grapple point. We're going to set the current grapple distance to the distance, which is the grapple point minus the active location, and the length of that. And then we're going to set isGrappling to true. Then in set grapple point local, we're going to set grapple point on the server, and this will make sure that everything gets synced up. Otherwise, we will have jittery mess. And now here's an example of the grapple if you did not call the set grapple point on server. I grapple, everything's zigzagging because my game thinks I should be in the air grappling, but the server thinks I should be on the ground. So I'm constantly redirecting upwards and the server is constantly pulling me down. A metaphor for life, if you will. Then on the server, we're going to do register new grapple point as well. And when you call register new grapple point on the server, all these changes are going to replicate to every other machine, so everything's going to stay in sync. Now we're just going to check out our isGrapplePointValid function. We just check if the distance to the grapple point is greater than our max distance. This is only going to get called when we're starting the grapple. We just assume the character has a good grapple if they're already set. Another thing we could do is to verify against cheating, we could validate by doing a sphere trace near the point to verify they're going to actually hit something. And we could also do a trace to the character to make sure there's nothing in between them. Because the way it's currently set up, someone on the client could just call this set grapple point server, and there's very little verification. There's just this much verification. So they could just cheat, put it above them all the time, and fly. So that's just something you got to look out for. We also need to override our tick component, and in here we're going to call the apply grapple function. This will make sure that every time we are grappling, it's going to apply the necessary forces to keep us in the air, falling the right way. Okay, first things first in the apply grapple function. We want to check if we are grappling, and if not, we're going to return. This is a guard statement. It just helps with nested loops and avoiding them. We want to get the difference between our actor location and the grapple point. The order of this matters because we're going to use the direction of it in an angle calculation in the future. If the difference is less than the current grapple distance, we are going to return because that means we have slack on the rope, so it won't do anything. Then we are going to get the velocity and normalize it to get the direction, and we're also going to normalize the difference to get the direction towards the grapple point. If the angle between your velocity and the grapple point is less than 90, we are going to return because we're moving towards the grapple point. We don't need to correct our movement at all. And this angle function, the inverse cosine of a dot product, is pretty much the only reason you'll ever need a dot product. So that's an important one to take note of. If the angle is less than 90, we're just not going to do anything. And then otherwise, we're going to project our velocity onto the plane defined by the normal. And so the plane defined by the normal means that if the plane were a pizza, the normal would be the little mini table that stands on top of the pizza. And then finally, we're going to launch our character with the new velocity, and we're going to override the x, y, and z values. Finally, we can look at the stop grapple functions. They're pretty simple. We set grappling to false locally, then we call it remote, then that gets executed on the server, and then the server sets it to false, which will send a signal to all the other machines to stop grappling. This should be all we need to get this grapple function working. Now we have to set up the inputs for this, so we're just going to copy the jump action, and we're going to do a grapple action. So now we need our input action function, so we're going to have a grapple pressed function and a grapple released function. Okay, now finally we want to do try set grapple local in our grapple pressed function, and then we want to do stop grapple local in our grapple released function. So now we need to bind the action to the functions in our class, so we're going to do this, and we'll have the started method go to grapple pressed and the completed go to grapple released of the grapple action. Alright, so now we should be able to start setting up the inputs. We're going to go into our input directory, actions, duplicate the jump, IA grapple, save that, go back to upper directory, IMC default. We're going to add a mapping to the grapple, and we're going to set it up to E, save that, delete that. Now we're going to go to our first person character component, scroll pretty far down, and then you're going to see this grapple action. You unhook that up to IA grapple, save. So now everything should be working correctly. So if we go into our client net mode, we can make sure we're playing with the server, and then we should be able to run up here, grapple onto this, and see now we're swinging around on a server as smooth as can be. So thank you for watching this video. I hope you liked it. If you got any suggestions on anything else you want me to do, let me know. I'll see if I can do it or figure it out. Thank you for watching.